Hey everyone, and welcome to this wonderful webinar for the latest release of Mari version 4.7 and one of its amazing features, Custom Procedurals. Today we're going to be discussing what Custom Procedurals are, how to create, use, and share your very own custom procedurals, and some of the best practices when making custom procedurals to keep them efficient and user-friendly. I'll also be showing you some examples of tools that I use in production, which will be available for you to download after the presentation. Very quickly, let me just introduce myself. My name is Stuart Ansley. I'm a texture painter working at Digital Domain in Vancouver, British Columbia, Canada. I've been in the industry for about 7 years, and I got my start working at an indie animation and game studio. From there, I jumped to television for a couple of seasons, and for the past while, I've been working on feature films. Prior to my film work, I worked as a generalist for many years, and one thing that I really enjoyed was look development in V-Ray, Arnold, and Mental Ray back in the day. I spent a great deal of time in Maya's Hypershade, so node workflows have always been super interesting to me, which brought me into Mari's wonderful node graph system, which has a huge variety of nodes for you to get creative with procedural texturing. So I'm sure many of you attending are familiar with the concept of procedural texturing, but for anyone who hasn't heard that term before, what I mean is making use of things like random noises, tileable textures, adjustment filters, baked geometry maps like ambient occlusion and curvature, and other utilities to create interesting textures and masks. It's an efficient and quick way to cover your model with minimal or no hand painting, which keeps things non-destructive and easy to apply and iterate. A procedural tool is created by connecting a bunch of this stuff together in a network that either manipulates an incoming image like paint or a tileable image, or creating a result all on its own. Here are a couple of examples of assets that use some nice procedural texturing methods to add detail and breakup. This is a dust and dirt mask set up with AO as the main driver of the mask. And here are some edge wear and scratches that show up on the convex edges of this model. Mari 4.7 introduces a new feature called Custom Procedurals, which is a special type of group node to improve the reusability and shareability of your procedural texture node networks. Now, why is shareability important in this instance? So, let's say your coworker comes up to you and says, "Hey Dorothea, I made this really cool dust and dirt procedural texture template in Mari. You should really try it out on your next asset." And you say, "Wow, thanks Ricardo, that's very kind of you. I would love to use your dust and dirt template." And so you go into Ricardo's work directory and you find his node graph file and you get all excited and you load in the template and okay, wow, nothing is organized, connections everywhere, things are on top of other things, there are texture reference files missing, and this is a little bit crazy. And he's like, yeah, there's actually some really cool controls to edit with it. All you have to do is search for level 68 and HSV 34. They're a tiny bit buried, but I'm sure you can find them. And you're like, oh, wow, thanks so much. The reality of the situation is that as good as Ricardo's procedural dust and dirt mask might be, it's hardly useful if you have to spend a few hours digging through it to figure out how to use it, let alone edit it, and you still don't have any of the reference texture maps used in it. It would be easier to simply start from scratch. So as you can perhaps guess, there must be an easier way. In previous versions of Mari, you have two ways to share your procedural node networks, gizmos and Mari materials. Gizmos are simply group nodes that can be exported and saved to your hard drive and can be called into your node graph through the tab or right-click create menus. They can have as many inputs or outputs as you like and can be great for creating utilities or masks. Nodes grouped inside of the gizmo can have sliders, checkboxes, and numerical inputs exposed to be visible by highlighting the node properties of just the gizmo, which means instead of having to dive inside the group and dig for what you want to adjust, it's conveniently organized for you in an easy-to-reach spot. Mari materials are the monolithic, multi-channel big brothers to gizmos. They live in your shelf and can be applied to either your node graph or layer stack, and they output preset textures for your material channels like base color, roughness, height, and so on. Just like gizmos, they can have exposed properties, easy to reach and easy to adjust. There are some drawbacks to either system though. As robust as materials are, they're not overly malleable, and you're somewhat locked into the predetermined outputs. Gizmos are highly flexible and can be designed in any way you want, but they're not accessible in the shelf, and they can't be used in the layer stack, and any texture files used in tiled, triplanar, or other nodes inside the gizmo will not be transferred along with the gizmo itself. Mari 4.7 introduces a middle sibling to the family with Custom Procedurals. Custom Procedurals offer all the flexibility of a gizmo, plus enhanced accessibility and a special package file format that bundles up and carries with it any referenced items like tileable texture files. Like materials, Custom Procedurals live in your shelf with a rendered or custom icon to give you a preview of its effect. Just like its siblings, Custom Procedurals have the ability to expose adjustable properties of its inner workings as well. Adding a custom procedural to your node graph is simple. Just drag it from your shelf and drop it where you want it to go and connect it to your network. They can be placed into a merge, into a mask input, or they can be placed in a network with information coming in to act like an adjustment filter. For a layer stack artist, the setup is simple too. Custom procedurals can be dragged and dropped into your layers as well, and you'll get a different reaction based on how these attributes, color, scalar, and mask, were set on the custom procedural's creation. With color selected, the custom procedural just gets added to the stack, either as a layer or an adjustment filter. Scalar procedurals will act the same way and sit happily in the layer stack on their own, but color management is turned off to preserve the linear information for your roughness, height, normal, or other raw data maps. If defined as a mask, the custom procedural can be dragged on top of a layer, material, or group and will automatically build a mask stack with that procedural mask as a base. Any tileable or referenced texture maps included in the custom procedural is bundled together with the .mpc file, so no matter where you're working, you'll always have properly connected maps. No more red X's of sadness. So, how do we create our own awesome custom procedural? First things first, custom procedurals are always created in the node graph, so we've got to jump over there to get started. We can begin in two different ways. If you know you're going to be authoring a custom procedural, you can create a custom procedural node through the right-click or tab create menus. Select it and dive inside with a control double-click or control enter. Now, typically I'll be working away on an asset and creating procedural tools on the fly. So another way to do this is once you've done some work and made any sort of procedural network in your graph, select the series of nodes, hit Control G to group, and then convert to custom procedural. The next step is going to be promote any attributes you want the user to be able to quickly customize. Lastly, we'll define if this should be a color layer, scalar layer, or a mask. And we'll need a name and tags so we'll be able to quickly search for it and find it in the shelf. If we like, we can create a custom thumbnail, or we can let Mari provide a default shader ball thumbnail. Now we can save it to the hard drive or system network, and you or a team member can pick it up and import the package into your shelf, ready to use whenever you need it. I can open up my shelf, create a new tab for custom procedurals, import my collection, and they can live here for whenever I need them. If I feel I need to update one of them, I can tweak it, export it again, and then the item in the shelf updates as I overwrite the previous version. Alright, enough of this training wheel stuff. Let's open up the throttle and see what we can really do with this thing. I've made a couple of examples, and these are all going to be available for you to download and play with as a free thank you for watching this webinar. So, welcome to your new VFX texture artist role. You're going to be working on the second season of a streaming episodic TV series. It's set in kind of medieval times. The heroes sort of hunt monsters and their magic and stuff. And the opening sequence is this big battle in a town, and you're going to have to build the environment. So here's the opening shot of the series. Please excuse my storyboarding skills. They're not necessarily up to par, but hopefully you can see what I'm trying to represent. The camera is looking down at this cobblestone road. There are people running past the camera, splashing in puddles. Fire is reflecting in the sky. The camera pans up to see this battle of epic proportions just beyond the buildings of the town. So your first task is to paint those cobblestones right at the head of the shot. Maybe not the most interesting thing, but you gotta start somewhere. We've got the camera locked in, the model is done, UVs are laid out and scaled for the camera, and we've got maybe about 5 or 10 minutes left in this webinar to finish this asset, so I think we'd better get started. Since we're a bit short on time, let's just see what we can do to get a rough first pass going. It's always good to plan ahead, so I'm gonna make a few notes of things I wanna hit right now. First, I want to get a tileable stone texture, but I want it to have a little bit of variety, little randomization, little scale shift. We can flip the textures around, and we should also add in a little random color shift here and there as well. Next, I see the edges of these bricks are all really smooth and CG. We should try and break the edges a bit. Maybe break a few corners, chip some stone away a tiny bit. Then, once we've got the cobblestones looking nice, we've actually got another asset to take care of, and we're going to look at kind of an interesting tool to mix and blend different displacement maps together for this mysterious creature that the hero comes across in this episode. So let's start by randomizing these bricks a little bit. We're just looking at the diffuse channel right now, and I've got this ambient occlusion sitting on top so that you can actually see the shape of the geo a little bit better. From my shelf, I'm going to grab this tiled random custom procedural, and for this example, I'm just going to drop it into a layer stack. Right away, we see this warning, missing random ID. This is referring to a geo channel that this procedural needs for it to work correctly. I've actually already baked out the random ID map and I've loaded it into my project, and all I have to do is convert it into a geo channel, either through the channel stack or using a bake point. And once we've done that, this should fix the warning message. And now that that's taken care of, we can look at these layer properties, and seeing what's there, it's kind of similar to a tiled procedural with a few extra options. So let's just start by dropping a generic stone texture on here and see what we get. We can play with the angle, position, scale, all that typical stuff. Below that, we also have some randomization options. There's also a control to change the overall scale of a random selection of bricks as well. We got some flip-flop controls to flip the X or Y scale of random bricks. Lastly, there are some different base colors we can apply to random bricks. Each color is multiplied over a different set of bricks with different strengths, and some sets overlap each other, so you can get some cool variations. If we compare this to a regular tiled procedural, you can see that we have a lot more variety that we can get very quickly. Let's take a really quick glance at how this is created. I can select the tiled random custom procedural in my node graph and either control double click or control enter to jump inside. Now, this is going to look a little intimidating, and truth be told, opening up anybody's project file is often really confusing, but I've tried to label things as best as I can. I've left some sticky notes here and there to help anyone looking inside to understand a little bit better. We don't have a great deal of time during this webinar to go over the nitty-gritty of the inner workings of this, but like I said before, you're going to be able to download these for free afterwards and look over them in your own time. Just to quickly go over what we have here though, we have right smack dab in the center our basic tiled image, and then upstream of that are all the controls for randomly changing the UVs, and then to the right is the random color variation. In this section here, we've got the UVs right here, and they get multiplied and manipulated in different ways based on this random ID geochannel. Downstream, we have a couple of color nodes that get multiplied to the tiled image, and again, the random ID is used to create the mask where those colors are being added to. Just a really quick important note, if you've used Designer a lot, you may be wondering why all the scale and UV transformation stuff is happening before the tiled image and not after. So whereas in Designer, you would take your image and plug it into a transform node to manipulate its placement, Mari works a bit differently. In Mari, the placement controls all happen upstream of the image, which is the same way that Maya does it with a 2D placement node. Alright, so we've got our color dialed in. I've jumped ahead a tiny bit and I've taken that tiled random custom procedural and I've set it up as a base inside of a material, using that as a source for some roughness and height information. Just to quickly show you how this is set up, let's have a look inside of the material in the node graph, jumping inside with Control Enter. Here is the same tiled random procedural as before with a little bit of an addition. We've got the out color like we did before, but I've also added this second out scalar output. All it's doing is taking the tiled image, but it's bypassing the color multipliers so that they don't get affected by the luminance of the image. And then I'm converting it to grayscale and linearizing it before sending it out. This is one of the really nice features of custom procedurals. If they don't do exactly what you need it to, it can be tweaked really easy to get what you're after. Alright, so one thing I want to do is break these edges and corners up so that they're not so perfect. To do that, I'm going to jump over to my bump channel and I'm going to add a cloud noise and set it to multiply just to start digging into bricks randomly. Now, I got to mask in where I want to remove the chips and chunks from. So I can grab this bricks mask procedural and drag it right on top. Because this was published as a mask procedural, it will automatically create a mask stack on top of this layer. And as easy as that, we got some nice broken edges. Now, under the hood, this procedural runs off some curvature baked maps, with one of which that is very blurred, and with this mix slider here, we can control the tight and broad influence of this edge wear. There's a slot to input a custom tileable image to use as edge wear instead of a generic noise. And we have a couple more controls to tighten or broaden the edge wear to change its strength. And now we got it nice and dialed in. Let's again check out the inner workings of this procedural inside the node graph. Again, we're just going to go over this really quickly right now, and you can look a little bit closer with the free download package at your leisure after the presentation. We've got our two different curvature geochannels here, some noises, and some math. The edges essentially get their gamma remapped by the noise with this power node, which pulls and pushes the edges of the gradient in and out. The noise gets its value remapped with this linear node with the upper limit set by the user. The same value is used to add contrast to the final output, crunching the mask like the jagged edges on the brick edge wear. And with that, we've got some nice edge wear on these bricks. So we've got a good start on these cobblestones. I think that we can now submit these to dailies for the supervisor to review. So let's have a look at this mysterious creature that we're going to be painting. Alright, so here we got this horned creature dude. A first pass sculpt has already been completed, but the client sent back some notes. They want to get a lot closer, they want to show it off in the show more, get a lot more hero shots of it, which means we need to add a lot more skin surface details. A great way to do this is by painting in displacement information captured from a real-life scan of a model. A really nice new technique with these scans is getting a multi-channel displacement map with varying information in each of the channels. Red holds the general, somewhat broad level displacement, green holds smaller frequency bump information, and blue holds tiny surface details, giving the skin really nice breakup. It would be great if we could mix and blend the different channels together to get a more refined displacement map with all of the information combined. Using this multi-channel displacement mixer procedural, we can do just that. Let me do a really quick paint job on this guy using my multi-channel displacement map, just over this cheek region here. With this plugged into the bump channel of our shader, you can start to see some of the effect on the surface of the model, but something is missing, and I'll tell you what in just a second. I'm going to drag and drop this Mcd Mixer procedural above this on the layer stack, and instantly the bump changes. So, what's happened? By default, when converting images from RGB to scalar data, Mari, Nuke, and other software are just going to grab the red channel and use its luminance, which means we lose the green and blue channel information if we don't mix them together into a single grayscale map. This Mcd Mixer procedural takes the incoming RGB information, mixes the channels together, and spits out a single output. These sliders control how much of the different frequencies you want to blend together to fine-tune the result of the skin surface displacement. This is an example of a custom procedural that requires information either as an upstream node or a layer that the Mcd Mixer can sit on top of. This custom procedural acts like an adjustment filter, taking the incoming information, manipulating it, and then spitting out something new, much like a levels or HSV. With this, we can paint the multi-channel displacement information over the model and then use these sliders here to tweak the result, removing or adding different levels of detail to the map. Our assets are already starting to look really great, and with the rest of Mari's toolset, we can further refine the procedural stuff that we've built today into some AAA hero quality work. I hope I've shown you the power and customizability of custom procedurals. Using Mari's node graph toolset, we're able to create any type of tool we want and bundle it up into an efficient and shareable package to either use on our own separate projects, with other team members, or with other Mari users around the world. We looked at how we can create color, scalar, and mask procedurals and how to apply them to the layer stack and node graph scenes, and we've looked at how to add them to your shelf and grab them and use whenever you need them. Those three examples, the tiled random, brick edgeware, and Mcd Mixer, are just scratching the surface of what you can create with custom procedurals. I hope you found them intriguing and you'll grab the free downloads to play with after the presentation. Before we wrap up for the day, I just want to spend a minute going over a few best practices and some optimization tips when creating these custom procedurals. First off, keep it simple. The more complicated you get, the heavier the node will be in your scene. Also, keep the user controls simple. The more controls you add, the harder it will be for the user to understand how to use them. Bake and cache when your FPS drops. A lot of the time, creating heavy nodes is unavoidable, which results in a heavier load on your GPU, slowing down your frame per second, and can add to the spinning gray wheel of calculation frustration. If things start to chug, cache that layer or add a breakpoint to relieve the stress on your scene. You also have the added benefit of seeing the baked result rather than the unlimited resolution that procedural layers have. Mix and math nodes, the efficient cousins of merge nodes. They may be taken for granted, but merge nodes are quite powerful workhorse nodes with the ability to mix layers with different blend modes, swizzle outputs, and even do advanced blending based on luminance. All of those extra features can start to weigh down the merge node and can in turn slow down your scene if you have enough of them. A better alternative in the node graph is to use mix nodes. This is one of the lightest nodes available, and all it does is blend from one input to the other using a value or a mask. If you want to multiply two nodes together, use a multiply node instead of a merge. The same goes for add and subtract. To blend the multiply result, plug the original image into mix A and the multiply into mix B and use the blend amount to control the multiply effect. This seems really small, but over the course of a project with 100 billion layers, it actually has a pretty big effect on performance. Node graph versus layer stack. It's been said many times before, you can do a lot more with node graph than you can with the layer stack, and the same applies with these custom procedurals. Custom procedurals can have as many inputs or outputs as you want, but only one of each, the topmost, is accessible in the layer stack. If a custom procedural with multiple inputs and outputs is added to the layer stack, only the first input is connected to the incoming layer, and the first output is connected to the next layer. Lastly, ignore my first tip. Explore and get complicated. Who cares about the rules? Don't let me tell you what to do. Add as many things together as you can think of. Search for the limitations of the software on your own. You know your own requirements and the abilities of your hardware. I'm on a graphics card that was built in the Stone Age. Some of you are cruising on 3090 Titan RTX double-shot espresso macchiato NVIDIA cards. You'll know way better than me how complex your procedural nodes can get before you experience slowdowns. Go out and explore and have fun with it. Alright, thanks everyone for joining us today. I have some links and information here for you all to grab some free downloads off of my Gumroad. Just follow this link and look for the Mari Custom Procedural Examples product, and for the coupon code, type in MARI47JAN21. Please feel free to ask any questions you have about custom procedurals, Mari, no graph stuff, anything you like. If you want to follow up after the webinar as well, I'm often online on the Mari Discord, as well as Michael Wild's Discord server, which I've included the links for as well. Thanks again for everyone for attending. I'm really looking forward to answering any of your questions.